And we're going to like post the recording online so then you guys can go over that again.
Yeah, and we created a bunch of, not a bunch, but there's some sample code that you can also take a look at as well. Well,
yeah. Are you here for the review?
Oh, yeah.
For Python?
Yeah. Okay.
Okay, nice. We're just gonna, we said we're gonna go over the presentation first. And you can like sit down if you'd like. Okay, so we're gonna focus a lot on object-oriented programming and big O notation. So okay, yeah. So also the code we are gonna like do today can also be found on this GitHub. Are we gonna post this presentation online as well?
Yeah, so the presentation's already posted, and you can go to that link later, as well as on the YouTube page, and you can find the recording as well as all the slideshow and the code.
Okay, so object-oriented programming. You guys have probably seen this before in class, I hope. Yeah, so object-oriented programming is basically you're creating an object. So you could create an object for like an animal. You could create an object for like a point. You can create whatever object you want, basically. And you have your methods and you have your properties. Okay, so we'll go to the next slide because I think it does a better job. So here's an example of a point class, right? So we have the definition and you need to use self as an input. So make sure when you're coding on your exam, you're using self as an input. And so example, we have like set X, set Y, get, move, things like that. Have you guys seen before the plus and equals operator? Yeah. Do you guys know, can one of you tell me what it is? Yeah, so yeah, so you're adding and you're assigning at the same time. So basically we're adding dy to self.y. If you just say self.y equals dy, then you're just assigning it. But you need to have the plus sign. So you're basically saying self.y equals self.y plus dy, right? So you don't necessarily have to use this operator if you don't want to. It's kind of a short form. But if you see code like that, then you'll know what it is.
So yeah, for that specific example, the only reason we need to do the plus equals or the equals self, so the line 14 and line 15, we could do it this way, or we could do it as Rachel mentioned, self x is equal to self x plus dx. And the only reason we need to do that is because with this specific example, with the move function, we're moving the point from the current position and we're moving it by an offset. So maybe just to backtrack a little bit, basically, I don't know how your prof is doing it this semester, but when I was taking the class, they would give us a list somewhat similar to this, where they would provide a list of functions that your class needs to have. So in this case, they're asking for functions that set the value of x, set the value of y, return the two as a tuple, and then move the object. So that's why we created those functions in this class. And
yeah, so this is kind of like an example of a question you could get, and then this would be the solution you would do. So if you get like these methods that they want you to implement for a class named point, then you're going to want to do it like this, where you're going to first say class point, right? And then define all of your methods. It's also good to, if you guys want to add comments in your code, like we definitely recommend that. It's definitely a good idea to like explain what you're doing so that they know. And even if then you made a mistake, for example, they would know your thought process. Yeah. Wouldn't you say?
Yeah, so I'd agree with that. This is going to be very obvious for those of you that are taking the Java class next semester, is they will actually sometimes, not always, but sometimes they will reduce your marks if you don't leave comments. So just a good practice to get into now while you're starting off, if you're starting off.
IEEE1120 is Java?
Yes, that's next semester. Yeah, so just note for that one, you have to write comments on the exams. For this one, I don't think it's required, but it's highly recommended.
Yeah, and you could get marks from
the points,
even,
yeah,
because you're explaining your code is like one of the most important things. Yeah. So do you guys have any questions about point as a class, for example, that we've just gone over? And also like you're doing self dot. That's why you have to do self as an input, because you're setting X to itself, right? So you're setting the input to itself.
Yeah.
Do you have a better way of explaining that?
So basically it's like a reference to the object itself. I don't know how else to explain it. It's just a reference for the object, and typically you'll see it in the next few slides. When we refer to a copy of that object, you'll do, let's say, P.
Yeah, we'll explain it in the next slide.
But you need to have the self dot. You need to input the self as a parameter so that it has something to reference the rest of the parameters that are stored.
Yeah. So here's an example of the class point. So first you're going to define it. So P equals point, right? And then you say P dot set X to 12. And so if you look back at set X, right, you have input self and you have X, right? So when we go to the next slide, you see we do P dot set X, we're setting X to 12. We do P dot set Y, we're setting Y to 1. And then we say P dot get, which we defined here, and it returns the value of X and Y. Yeah, so you define your variables, and then these would be like the outputs, for example. And then P dot move, P dot get, those are all like the return values. So yes. Yeah, so that's just basically like how you would use your class, everything like that. Yeah, you can come back.
Right, so
All good.
I'm gonna just go get the cookies. I'll be back in a second.
Yeah, there are cookies coming. So I guess that's the best part about coming in person. Then we're going to be talking about overnote loading and the constructor init. You guys have used init before, right? When you've done your stuff. Yes. So init is when we're creating a class. So it's like the constructor. So when you define point, you're defining it with like and the initiator is like the default that is always called. So you don't have to call init like the other ones. If you remember, like some of the other like methods that we've defined, you have to like call that function. This one is always called because it's like predefined for every class kind of thing. Like it knows to call the init when you construct a class. So this one, for example, you know, for our so for the point before, when we just had the methods and we had no init at all, we had to call the methods and say like set X, set Y, and everything like that, right? For this class, we've made a constructor, and so we're inputting self again. Self always needs to be inputted. You shouldn't forget it. And then we're also inputting the X and the Y coordinates. And when the constructor is called, if you guys can see, like the constructor is called and it's already setting X and Y, right? And then overloading. Do you guys remember overloading at all? Yeah, overloading is kind of a way to deal with different kinds of inputs. So for the example we had before, there was no input. And then for this example here, we could have an input of X and Y already, right? And so for this one, for example, it does the little arrow and then the none, right? And that's overloading. So when we're overloading, it's saying you can put in an X and a Y, or you can put in nothing. And then if you don't put in anything, it's going to be set to none. Does that make sense? So it's kind of, overloading is kind of a way of giving you options. So it's kind of a way of making it so it can accept more inputs. It's, for example, so like if you don't do the overloading, you're going to have an error if you don't put anything in it. For example, you're going to have an error if you do put anything in it. So you want to be able to overload so you can account for the different options, like the different versions of what you're going to be putting into your class. So yeah, so this one, for example, it's supporting 2 inputs, but it's also supporting no inputs at all. And so that's kind of what overloading does. And then here's another example is you can put default values. So the default value would be none, but you can also set it to 0 for both of them, right? So by we're setting it to 0 as an input of init, but that doesn't mean that it's always going to be 0. You can still put values into it, right? But this is an example of like you're presetting it to 0. Let's say you have a point and you want it to be like preset not to 0. You want to preset it to like 50 for both of them. You could do that here too. So yeah, so that's an example of overloading and also like presetting your values. So let's say for one of your questions on your exam, you had it where like they said, make sure like the default is set to like 2, like it says like the default value is set to 2. Then you make sure you put in here the default value is 2. So yeah, just make sure you also read the question because it could do something like sneaky like that. And you're going to have to make sure you're doing like the initializing with presetting values. You could have make sure you could be doing overloading. There's also different like notations for this. So you could have this one too, where you say it equals none instead. So I would recommend like looking up online, seeing which one you feel most comfortable with and doing it that way and just like consistently doing it the same way you practice so that when you do it on your exam, you'll be ready. Yeah, free food, have some cookies. And then it's not only the initializing we're overloading. I'll let us get the cookies opened. Yeah. Yeah, so the you guys can have a cookie if you want now, after, whatever. So like it's not only, I showed you guys the initializing that we're overloading, but it's not only the initializing, the constructor that can be overloaded. So there's other functions that can also be overloaded. So for example, add, subtract, multiply, everything like that can be overloaded. So for addition, for example, you could do overloading so that you can have one value you're adding to itself. You could have 2 values that you're adding together. You could have 3 values you're adding together. And by overloading, you can account for all of those cases in one function. So let's say you set them all to none to begin with, and then you can say, okay, you only want to add 2 numbers together, then you can account for that in your function. You want to add 3 numbers together, you can account for that in your function. And so by doing this, it lets you account for all of those different versions, basically. Do you have anything to add?
So just to add to that, you can also use this if you're doing some odd things with your functions. So let's say you have with your objects, let's say you have an object that isn't either like a number or a string. Usually when you add the 2 together, it'll sort itself out automatically. But let's say you have an object that, let's just call it the object person, and you're trying to, and when you're trying to add one object to another, it will throw an error or something like that. But let's say you want to add a specific field or a specific variable in those 2 people together. So if you have 2 different people and you want to add, let's say, income together, you can create a custom overloadable function that combines just those 2 fields. And it's kind of to give you more flexibility with what you're doing and what you're able to do.
Yeah, so it gives you like different options. Like as I was saying, it gives you different options. So it gives you different options for how many different inputs you can have, but it also gives you options for the different types that can go into your method as well. Yeah, so here we're going to go through kind of an example here. So it's going to say P equals 0.55 where you put inputting 5 and you're inputting 5, and it says what happens if you try to print point P. And I don't know if you guys remember, but for point, we haven't yet defined any print. There's no print defined, so it's just doing the default, which is defined by Python. So
this one's str.
Yeah.
Yep.
So what do you guys think is going to happen if we try to print P in this case? Yeah, it's okay.
It's probably going to be printing something called something object at some address.
Yeah, exactly. You're right. So exactly that. So it's printing the object at that address. So instead, we're gonna do overloading with the string because you don't really want it to print object at this. It's printing it because it's just printing the object itself. It's not printing like what's in it. It's not printing it formatted. if you like, normally if you do like print a string, it'll print the string, right? If you do print this, it just prints exactly what it is when you use the default print. When you say, Stefan. So if we do, so now we're going to overload it and we're going to define a class, and you're defining this inside your class point, and you're doing definition string, and then you say return. And so this is the formatting we want to do, right? So we're defining return point plus the string of self.x plus comma plus, so you're adding them all together. I think you guys know how to define, like we're doing the string method, like we're putting self.x into strings so that we're not going to have any errors. Because if you don't do that, you're trying to combine all together strings with like an integer, for example. And so we don't want to do that, right? So here we've done the overloading with the string function. And so now we're going to try to print it, and it prints it in the correct formatting, right?
Do you have questions about that? Or does that make sense? Yeah.
Okay, cool.
Yeah, so just what I want to add about this section is I don't know how much your prof covered this, but definitely memorize how to do the string one. The length one is also important, but when it comes to these overload, like the overload functions, I would personally say the most important one is the initializing one, just because it's generally the first one you'd want to create when creating a custom class.
Yeah, and also for the initializing one, you're definitely going to be doing it. Like there's no way you're not going to be asked to like create and initialize your class. Like on your exam, like I pretty much guarantee you're going to have a class and you're going to have to write methods for it and you're going to have to initialize it. I bet you guys have already been like doing that, but it's always good to like remind yourself, practice, whatever. Sorry. Yeah, we've done this. Okay, and then inheritance. You guys remember inheritance? So here's an example. We have a class called animal. We have set species, set language, speak, and then get the species. So we're going to set the language of the animal to lang. We're going to print what it's going to speak. So in this case, it says I am plus self.species, I speak. And we're not doing that string because self.species is a string already. Oh yeah. Okay, so then here's an example of inheritance, right? So we have animal, import animal. So we're then going to define a class bird, and in brackets we put animal. So it's inheriting from animal. So bird is like inheriting all the methods from animal. It's yeah, everything like that, but we can redefine the methods. So it might be inheriting everything, but let's say for this example, we've also done bird and we've done dog. And in this example, we want speak to be different, right? So since we want it to be different, we're going to redefine it. And for example, this one we say speak self print, and then it has the curly brackets dot format self dot language. And basically the formatting looks kind of weird. I know, but it's going to put, and it says ×3, right? And so it's going to print 3 times self.language in the curly brackets. So it's going to print like example French inside, it's going to print French 3 times.
Sorry, just to answer the question from chat. So basically the question was, what is the difference between REPR and string or STR? Basically, string is meant to be human readable. So like, let's say you want to print something to the console. If we can go back.
Yeah, I'll go back.
So like, let's say in this example, we want to display the value to the user. We would want to use string. REPR is kind of similar, except it's more used in debugging. At least from the real world experience that I've had. So basically the string you'd want to use if you're displaying something to the user, and you can use REPR in other scenarios. I hope that answers the question.
Have you guys had any like cases where you've been asked to use REPR before, or mainly just like the string one for any of like your labs or anything? Probably not, I suspect. So you'll probably be asked the string one. Okay, you did do it in a lab. So yeah, if you guys, go over it and yeah, make sure you can do it like both ways.
Yeah.
Maybe we can go over like an example at the end where we can use both if you guys want to go over it, and we can compare them.
Yeah, we'll go over an example at the end.
Yeah, to make sure you guys understand. Okay, yeah, so we were here. So we're redefining it, right? We're definition speak for different birds, animals. Yeah, one thing, make sure you guys remember the try to memorize your like the syntax. So to make sure you, because yeah, try to like do it without looking, like write on your paper and like try to do it without using your your IDE, because sometimes you can be on the test and be like, oh no, how do I do the syntax again? So just remember, like bird, you put the animal inside the brackets. That's how you do inheritance, right? And then inheritance overloading. So here's an example of like the different results, because remember we redefined speak for each version. So we created an animal first, and we're going to do squirrel.getSpecies, squirrel.setLanguage, print, and then squirrel.speak, right? And so in this case, it's going to print from the way that animal has defined it. When we do the bird one, when we do parrot.speak, it's going to be defined by the one we did in the bird definition. And when we do dog.speak, it's going to do it as the one we've defined in the dog definition. So here's an example, flying squirrel, I'm a flying squirrel and I speak parrot, squawk, squawk, dog, wolf. So it's like printing, this is an example of it's printing out all of the different things from this. So like that could be something you're given where you're asked like, oh, here is some code, what does it print, right?
Yeah, so just to add on to that, basically, like the way you might see this on a exam is, let's say you have class A, and in there it is inheriting from class B and class B and C are inheriting from it. And let's say you might have we can do another example of this later on, but let's say you might have class B, which is inherited from A, and it says print a function, and you see both the same function in class B and in class A. Which one is it printing from? Is it printing from class B or class A? So like that's kind of what we're trying to demonstrate here.
So for example, in this one, we have class bird and class animal. We have the same function in both, right? We have speak in both animal and in bird. And bird isn't going to use the animal one because it's defined it itself. So it's only going to be using the one that it defined itself. And if it can't find it at its own, it's going to go and look into animal. So it looks at its own functions first, and then it looks at where it's inheriting from after that. So if it doesn't find it in its own, it goes and looks where it's inheriting from. So remember, like you go to it's going to go to itself before it goes to its like parent, right? Yeah. And so there's the example. If you guys want, you could always like go through this yourself and like try it to see what everything would print. And then we're going to talk about custom errors. Do you guys remember doing this in your labs? I kind of assume that you would go over them. So for example, so here's an example. We're using a queue. You guys remember what a queue is? So a queue is like, I always remember this like a line, like, you know, when you're in line to go get like a sandwich, a queue means the first person who gets there is going to be served and then they can leave. So it's first in, first out. So whoever goes into the line first can go out. And then the opposite of that is a stack. So that means like you have a stack of plates. The one that's on the top comes off first. You're not going to go and try to grab the one at the bottom because then it's hardest to get. So whatever's on top, you take off. So stack, top off. And then for queue, first in, first out. I don't know how much you guys went over that. So if it's in your lectures, like review it. And so for this example, we're saying if the queue is empty, so there's like, for example, that line example, there's no one in line, then we're going to want to raise an empty queue error. And we have to define that error we've just presented. So we have class empty queue, and you put in brackets exception. And then this just means pass, but like it means we're going to add the code. So this example where like they might ask you, okay, here's the class, here's the error, like right in the pass like area, for example. So yeah, if there's like, so this is a case where like you have to have something in the queue and able to be able to dequeue, which dequeuing means removing something from the queue. So like serving a customer in the sandwich line, you're going to serve them, they can leave. Right. So here is an example where we go through the code. Were you going to add anything?
I was going to add something. So just when you're raising these errors, they will typically or they will probably provide you a case in which the error will be raised. So as Rachel mentioned, we're going to be raising it if nothing is in the queue. So another function in the class, which isn't displayed here, but you'll see it in the code that's available online, is that there is a function called isEmpty. So where every single time we're dequeuing something, we just check to see if it is empty. And if it is empty, it will then raise the error with the message that we provided. So that's the reason we don't need to return anything, is because if the if statement runs, it's not going to reach the return anyway. So because the error is thrown, so we don't really care about returning anything in that function if that's the case. If you guys understand what I'm saying.
If it gets to like the raise, it's going to like leave the function. It's not going to stay in the function to get to the return section. So the raise will mean it's going to leave the function. Return, if it gets to return, then it'll return the value. Otherwise, it's going to go into this function and say the exception. And then we can look at the, sorry, you go for it. So here is an example. So we define the queue. We say we're going to add apple, we're going to add banana, and we're going to add cherry, right? And then we're going to .dequeue. And if we, for example, if we put apple, banana, cherry, which one is going to come out first? If we do .dequeue. Yeah. So the first one that comes in is going to be the first one that goes out. So apple is going to be dequeued. Then we're going to dequeue banana. Then we're going to dequeue cherry, right? And then it should be empty after we've dequeued all three things. And so then we're going to ask to print it again, right? And it's an empty one. It's being printed. It's going to go to the exception. It goes over to the exception. So here we are. We have apple, banana, cherry. Apple, banana, cherry has been printed because it's been dequeued. And then it prints it. It's empty, and it raises the error. So it says raise empty queue error. And so it raises the error that's been defined. And yeah, so you can define like different errors for different classes and everything like that. Do you have anything to add?
Yeah, so like you'll see if you continue on, you'll need to raise, like there are errors that are built into Python, but when you get into more advanced code, you'll have to write your own errors. So for example, one that I was working on recently, it was a network communication. Like this will not be in your class, but it's just an example. And I created a custom error that would raise if the network connection was disconnected. So that's just an example of a type of error that you might encounter in the future. But for an exam, you'll likely be given what the error has to do, and you'll just have to raise it or add the code where it will need to be raised in the function that they gave you already.
And it's also because we want to, it's better, like it's good to define your own errors. And like, let's say for the queue, we don't want to be trying to dequeue or do anything when, because we're trying to dequeue an empty queue. We don't want that functionality to be possible. And so we're going to throw an error. So if you want to prevent people from doing things with your code that you've defined and everything, then it's good to throw an error.
And also it provides you the opportunity, I'm sure you've done error catching. It provides you the opportunity to catch that error, that specific error. So instead of having a more general error, you can have the specific error and you can specifically catch that one and do something else with that code. So for example, instead of like what we could do with this example is if the empty queue error is raised, we can have it display a message, like an error message saying that there's nothing left in the queue. Would you like to add something to the queue, for an example? Like that's just an example of what we could do with this specific one. If that makes sense.
Okay, big O notation.
So just any questions about
any questions about that? Okay, big O notation. This is always fun. So big O is the relationship between a number of values entered into an algorithm and the number of steps or operations required to complete the algorithm is represented by this variable. So big O is when n represents the number of operations. So n is the number of operations. If you guys remember big O from class, it's kind of a way of defining how your code functions. If it's what's the word?
Yeah, so basically it's it's like a theoretical runtime of how long your code would take to execute. And it's kind of important when you have bigger projects or more variables that are coming into the function or the algorithm that you're working on. It's basically just a way to theoretically determine the efficiency of your code.
So like big O of like 1 is way more efficient than big O of n squared or n cubed.
Yeah, so here we have just like a quick, I'm sure you've seen the chart on the left from your lectures. It's just a list of all of the different ones that are typically used. And on the right, we have the like a graph that kind of displays the efficiency comparatively. So it's really hard. It can be hard to do, but you really want to be aiming for a log of n or a log of, or sorry, O of log n or
Below that.
So that basically means that your code is like, that's the peak efficiency that you can possibly have. I don't think you've probably learned a lot in this course, but later on you'll see it in different search functions like hash maps and stuff like that.
Yeah.
You'll see that the efficiency is close to that. So for example, I think right now you've been doing searching by just iterating through an array or a list, sorry. And that can be O of n usually. But later on, you'll see hash maps and other kinds of functions for storing data that are a lot more efficient.
Yeah, big O doesn't really go away. Like you're gonna have to use it for your next class. Like,
and you'll have to use it in the real world.
Yeah, they'll like in interviews, they can ask you questions about it. Like, definitely very good to know.
Yeah. So basically it refers to the worst case scenario in your code. So let's say we have a if we go back to this, let's say we have an O of n, so that's the linear one, and we have a quadratic one, which is O n to the power of 2. We'd be referring to the one that's higher. So that would be the general, like the overall big O notation would be O n of 2, O n to the power of 2 instead of the 2 combined, if that makes sense. So we'll Rachel, I don't know if you have anything to add, but
yeah, so it's like, for example, it's also looking for the worst case scenario, not the best case scenario. So if you have a for loop, right, and there could be a case where your for loop only runs one time, right, where it's O of 1. But there's other cases where it could run so many multiple times. So there could be a case where your for loop returns right away. But there's a lot, you have to look at the worst case scenario. You can't look at the best case scenario. So when you're going through the code, make sure you think of how it could take the longest to run.
Yeah.
And then constants are not important. So like O of 2 of n, it's just O of n, right? It doesn't matter if it's done n 2 times, still just n.
Yeah, so for an example where you might see that is, let's say you have 2 for loops, but not one inside the other. You have one for loop, you let that one finish, and then you have another one underneath. You may think that that's O2 of n because there's 2 for loops that run through through your list, but that would actually just be O of n because it's not I don't know how.
Yeah, because it's only n number of times that it's gonna be going through both. The case where you have it's n squared is when they're nested within each other. So that's when you have to go through both iterations.
And we'll go through an example of that coming up.
Yeah.
So here's just a basic example with of a complexity of O to a constant. So this would actually be O of 1. Is you have we just have a function that moves some variables around. So we just take in this example, we're taking the first value from our list, and we're just multiplying it by 20, and then dividing it by 3 and returning that value. So there's no like the time that it takes for this function to complete is consistent whether or not you have one item in the list or you have 10,000, because it's only taking the first item. And we can run these later because I do have all the scripts for these. Actually, should we just do that now?
Yeah, we can do it now.
Here, so actually, I'll give a quick demonstration. Actually, sorry, I don't have it for this one. I have it for the rest of them. And we can see how long it takes to execute. But for this one, just because we're retrieving the first value from the list, it will be a consistent time.
Yeah. And you're also like, you can look at it and say, oh, okay, I noticed there's no loops. I noticed there's no recursion. I don't think you have recursion on your exam, but that could be an example. And I noticed there's no other methods called or anything like that. So it's in its simplest form, right? So that would mean that it's a constant. So like, yeah, keep your eye out for that when you're looking at big O notation, those different things. And so here's an example of the graph for it.
So like on the bottom, we have 0 to 1,000 lists or items in the list, and the number of times the operation is repeated per cycle is just one. So for every single time, or sorry, regardless of how many items are in the array, the operation is only run once. So that's why it is O of 1.
So then here is O of n. So you look at this code, you say, oh, for loop, notice that. So it's run n number of times. So it goes over that for loop and it says for val in values. So for all the values in values, vals in values, it's going to keep iterating over, right? And all of those iterations mean it's going to be more than a constant, right? Because it's doing that for loop, it's going over everything. And so because of that, it's O of n. If that makes sense.
Like the simplest way to put this one is I'm sure you're quite familiar with looping through a list, is it has to loop through every single object. So that's where the n comes from, and it only loops through every single object once. So that's where the O of n comes from.
But there's ways they could actually kind of trick you and write bad, like it would be kind of bad code, but there are cases, for example, for this one, if return was within the for loop, for a return sum within that for loop, it would be a constant, for example, because it's not going over everything, it's returning it right away. That would be very bad code to write, but it would be a constant. So I guess that would be an example of how they could trick you. But if that, for example, if the return is in an if statement for like only if it's equal to one particular value, that would still be O of n. Because it's still, the worst case is that it would have to keep looping.
Actually do an example of that really quickly. Okay, so looking at, so I just added a little bit of code here that to show you how many different times the operation runs. But basically what Rachel was trying to explain is, so here we have our return statement. And let's say we took that return statement and placed it here. It would then count as O of 1 because it would be returning on the first time that the loop is run. But if we did something like if sum is equal to 10, and then we return the sum, oh, sorry, it's bad code, then we would still have to consider the worst case scenario because it's not guaranteed that it will run the content within the if statement.
Yeah, but there would also be, they could be even like more tricky and say if sum equals 0, what's going to happen if sum equals 0? Sum was set to 0, and then it's never going to be, let's say like if this isn't here, right? For example, then it's going right into it and it's saying sum is equal to 0. It's also going to be constant again. So kind of look at it if they're being like, if it's no matter what case, it's going to go out right away, then you could say it's constant. But most cases for for loops, it's going to be iterating over everything and it's going to be O of n. Right? Yeah.
Does that make sense? So basically you just have to be careful and watch out for any possible like branches that they might include and try and consider that. So yeah.
Yeah, and I guess that's why we said it's the worst time. So it's the longest time it's going to take.
So I'm just going to run this really quickly. Sorry. I don't know if it's going to be as visible on this one, but it's definitely visible later on that the runtime does increase significantly. So you see this one, it wasn't very apparent because we don't have that many extra items, but the number of operations does increase with the increase in the number of items in the list.
But if you were to look at a constant one, it could just remain 10. It could say 10, 10, 10, 10 instead of like 10, 100, 1,000, etc.
Does the linear complexity one make sense to everyone? Yeah. Okay. And here's just a quick graph to give you an overview of what it looks like with the more numbers placed inside.
Okay, so then n squared, you have two for loops, right? So if you guys remember, this is a nested loops. So for nested loops, you're gonna have, it's gonna go over the first loop in the inside, and then it's gonna go on the, like, so the outside is gonna be going over and the inside, right? So for example, like you have, if this was just like values like range 1 to 10, the outside is set to 1, and then the inside goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The outside goes 2, the inside goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next one goes to 3. Does that make sense? So because it's actually going over everything n squared number of times, right?
So
The inside goes over for every value of the outer loop.
So just to provide an example with that, because it is starting to get a little bit more apparent with this one, the delay in processing time that we experience. So it's basically the same code. I just have it count the number of operations that is completed. And when we run that one, we can see it is still going quite quickly, but the number of operations is increasing dramatically. So we go from 10, a list with 10 items, we have 100 operations. That makes sense because we're doing 10 values. So we're looping through one loop once, the other loop twice. So that's 10 times 10. With 20 items, we're already at 400 operations. With 30 items, we're at 900, etc. So yeah, it's already a lot more inefficient. And when you're coding, you'd want to try and avoid having nested for loops in a lot of situations, but sometimes you just can't avoid it. But yeah, so that's that when it comes to these. And they're probably gonna again try and trick you in different ways. So they might do again, they might do like a return statement here, which on the first time it's run would immediately just return a value. So that would be constant again. But generally, and they might also do stuff with the if statement. So if sum is equal to
or they could do this as well, for example.
So
do you guys know what would it be if it's returning sum here? What big of O notation it would be? Yeah,
because it would run through the
first for loop.
Yeah.
But then it wouldn't run through the outer for loop. So you're right.
So basically it'll run this one once. So that's a constant because
it'll run through the first for loop once, but it won't run through the outer for loop because it's gonna go and say for this value, it's gonna go through the first for loop, and then it's gonna get here before returning back, and it's gonna return. So it's not gonna iterate over this because it's being returned here. If that makes sense. Do you guys like know your like nested loops well, or do they get confusing? You guys got them? Okay, nice. Yeah, so just like watch out for like kind of, it's good to like iterate over the code yourself and everything like that.
Yeah, they will try and trick you by putting random return statements, random if statements, if else sometimes. So and one thing we didn't put in this presentation, but one thing you might encounter, so this is just something to note, is that you might have for example this here, and then they might put an if, they might put like an if statement. So let's just say if value is equal to 2, and then they might do another for loop inside. Okay, it doesn't matter. There's an error in the code, but if we have this if statement and the for loop statement and the for loop, which is inside of these other two for loops, does anyone know what the
and the return isn't here, right?
Yeah, sorry. Yeah, let's just ignore the return. Does anyone know what the complexity would be now? Sorry. Does the question make sense?
So yeah, we have two for loops and we have an if statement where there's another for loop.
Okay, so again, because big O notation is based on the worst case scenario, in this case, even though the likelihood or unlikelihood of, oh, there we go. Yeah, so that's correct. The big O notation would be O n to the power of 3. And the reason that is because we're looking at the worst case scenario. And in this case, the worst scenario is if we run 3 nested loops inside of each other. So we're kind of ignoring the if in this case, because there is a likelihood that it will happen. It doesn't say if the value is equal to null or whatever, even though that might be a case, but basically the likelihood of that if statement running is possible.
If you were looking at this code, for example, and you look at it and you say, okay, there's an if statement. Is it possible for value to equal to 2? So you look through the code and you make sure that that's possible, because there could be a case where it's never possible because it's never set, right? So you look through it first and you say, okay, could it get to this if statement? And if it can, then you look and you say, okay, well, there's another for loop that's nested inside of it. So that means it would be O of 3. Yeah. So there could be scenarios where that's not possible, but it's very it'd have to be very specific. Most of the time it would be possible, but you have to look at the code, like the context of it.
Yep.
Yeah. And so then we have, here's the graph for n squared. And then we have O cubed. So this is 3 for loops nested within each other, right? And so you have O of n cubed because all of the for loops could be going right on the worst case scenario. And then this is a horrible runtime. You don't want this, but it is possible that this could happen.
Yeah, so this one I can show you the example. So you see we're at 300 items and you can see the number of times that it's processing is a lot slower, and we're at 400 items, 500 items. It's stuck now, even though it's processing, but you'll see it'll eventually get it done. So these are the kind of runtimes you want to try your best to avoid.
And this is also why like big O is important. Like it's important if you run your code and it's not running fast enough and everything like that. And that's because, and you have to know why that is. And so that's why like big O is like a good thing to like look at and like analyze your code.
Like pretend you're trying to move 10,000 customer records and it's taking like this example here. It's not that important because we're just summing numbers, but let's say you're trying to move customer data from like one location to another location. You don't want to be taking hours to move 10,000 records. So it's important that you try and optimize your algorithms as much as possible. And
another thing that they could ask you, for example, is they're going to be like, oh, it has like we have 3 nested loops and it's O of 3, O n cubed. How can we make it more efficient? Right? Like, how can we change this code to make sure we don't have these runtimes? And then you're going to have to analyze it and see if it's possible, everything like that. So for like, so for this example, we're summing the 3 values together and it keeps iterating over all the values and summing them together, right? Can you guys think of a way where we don't need like this many nested loops to do it?
I mean, I'm just thinking off the top of my head. We can try this out, but I think we can just iterate through the whole loop once and multiply it by 3. I could be wrong. That'll work, right?
Yeah,
it should work.
So.
Yeah, it should work.
Or you could do the loops after each other instead of all together. You have to look at what the operation is inside, because if you have like, yeah. So make sure that operation could be like simplified kind of thing.
So I hope that makes sense.
Yeah, hopefully we explained that well. And here's the, quadratic complexity. And I think I remember like from like when I did it that you are always asked a big O question. Like they always ask you these kind of questions.
Yeah, so exponential complexity. Oh, sorry, I put the wrong titles on there.
Isn't this the same?
Sorry, I might have put the
Wrong.
code.
Yeah,
Shoot.
it's okay. We'll change it for the like when we upload it, and you guys can look back at the exponential complexity again.
But basically, well, I put the wrong title again. Sorry.
That's okay.
So basically
Me
with
telling you that's okay.
so basically with logarithmic complexity,
Yeah, so here we have a while loop. So for for loops, it's usually like of like n squared. You have to like look and be more analytical for while loops because it can be like log of n, for example. So for like the like here it says the example of logarithmic number of operations is proportional to logarithmic input. The number of times we can divide n is there for 2, like n by 2 before we get to 1. So it's because of this operation n equals n over 2 and n is less than 1. You're looking at the context, right? You're looking and saying, okay, well, the while loop would stop. It's only going to go this many times and we're doing division. So it's going to be log of n. Do you want to add anything?
yeah, so basically I think the thing that sets the log functions apart primarily from the
Like
ones that are
n squared
yeah,
n cubed.
like the ones that are to the power of something is that we know that it'll for sure run less than n number of times pretty much. So
like we
like for example with this one, we know that like if
we know it's not going to run n number of times because it can't run n number of times because it keeps being divided and because of the while condition. So if you're looking at it and you're like, okay, for example, the for loops, when you're going over the for you loops, you're saying, oh, it's possible for it to go n number of times because it's looping n number of times. For this one, we can look at it and we say, okay, well, n keeps getting changed in this loop. And that's another thing that's really important to look at. If, for example, we're like in the while loop, we're changing the value that while is conditionally asking us. And so it's changing that value. So that value isn't going to be n number of times because it's being changed. So this while loop isn't going to go n number of times, right? It's doing log of n.
So I have an example of that here.
Thanks, yeah.
So for an example, so we have, okay, the title is wrong. Here it should say the n is equal to 1 when we look at our code. But basically, so if there's, if the n is 1, there's 0 operations because it just instantly returns, because it's instantly 1, so it can't be greater than, so n can't be greater than 1. So it'll run 0 times, but we have n is equal to 10. It'll be 4 operations, so that makes sense. We do 10 divided by 2 divided by 2 divided by 2, and then because of some rounding error, but we can run that operation 4 times, and then with 100 before it reaches 1. So basically the thing to keep an eye out, as I've mentioned previously, is with for loops, usually it's you have a list of some sort, or you have a number that's brought in, and then it runs the for loop that amount of times. But for this example here, with the while loops, with the while loop, for example, it will, just because the nature of the function, it will run less than n number of times.
If that makes sense to you guys. One, like if you look at the code and you're like, oh, I'm really not sure if it's n, it's at log n. I recommend just like going over the code yourself, like doing an example of it yourself. So like do an example and run through the code and do like step by step of like what it would happen. And you're going to see that, oh, the answer is not n. It's not like, for example, 10. It's not, the answer isn't 10, right? So it hasn't done it n number of times. Yeah. Go for it.
Yeah, so pretty much the biggest way to differentiate it is start with your for loops. If it's a for loop, generally, obviously, as we mentioned, check for those oddities that they try and put in there to throw you off. But generally, if it's for loops, it's either, if it's one for loop, it's generally O of n. If it's two nested for loops, then it is
N squared.
n squared. If it's 3, then it's n to the power of 3.
And so, yeah, if they're nested, then it's going to be the number of for loops that are nested. Check out for the oddities. And then if they're one after another and it's going to be as many for loops as like only like n, right? And then look out for the while loops, because the while loops could possibly be n as well, or they could be log of n, for example.
Yeah. So just for example, if you see something like this, where we have 3 for loops, one right after another, that would still be O of n.
Yeah.
Yeah, it wouldn't be O, like you wouldn't label it as O3n. Just because as I mentioned earlier, you ignore the constants.
And other examples where you'd have like log of n would be recursion, but you guys aren't having that on your exam, I don't think. Did your professor tell you you have recursion?
No.
No. Okay. So that would be an example, but because you're not having it, don't have to worry about it. And then here's the graph again. Right.
Um,
And then the case where you have like the while loop and you have a for loop inside the while loop. That's like n of
that's
log
stupid,
n.
yeah. Yeah, so you can also, oh yeah. Oh, you think you do have recursion? Okay, we can go over that as well. It's going to take us just a second to pull up some slides. But basically, you want to.
You guys might, yeah, make sure you know if you have recursion or not. Maybe like ask your professor. When do you have your exam?
20th.
Okay, yeah, you guys have lots of time, so you can always like send them a little email and be like, do we have recursion or no?
Yeah.
you
Because some profs do and some profs
don't for these exams.
Yeah.
Yeah, so make sure. Do you guys remember what recursion is?
Yep.
Yeah, so you're referencing yourself basically. You're calling the own method within the method. Oh, he said he'd have a few questions on
Okay.
it. Yeah.
Yeah, all right. Let me I have some other slides that I can pull up to show. It's just going to take me a second to find them.
Do you guys have any like questions? Is there anything that like you find like easy, and then what's like kind of tricky for you guys when you go over stuff?
Well,
Yeah.
The trickiest stuff is let's say n squared plus n.
Oh, yeah.
The sum of bunch of stuff.
Oh, yeah. You guys have a bunch of those kind of questions where it's like it's less than plus this, and you have to like figure out which one it is.
Type complexity of n something plus n something and plus n something, like n squared plus n plus log n plus.
Oh, yeah. Do you get a bunch of examples for those, or have they not given you like that many examples?
Not much.
Okay, well, we can see if we can like we can always like add something when sorry, 1 second. Just pulling my computer. We can add some like more notes for you guys when we put these online to give you more examples of like how to do those types of questions.
Like can you reduce n squared plus n into n squared?
And like n squared plus n squared plus n.
Yeah.
I don't think you can you? Well, if you change the code, you can, but
like if you factor out the n, right? Like n times n plus 1.
Yeah.
So 1 is a constant. So I don't know.
Well, you can only like not consider the constants if you're like it's being multiplied, for example. It's kind of hard to we need some like examples to show basically for like so we can find some examples where like they do it, because it's kind of hard to say like hypotheticals and explain like a bunch if we don't have it like right on us. Yeah. Yeah, the recording is going to be posted online.
Yeah, it'll be posted on YouTube later tonight.
Yeah.
Yeah. Yeah.
And if there's like, if you have ones that's like O of n, it's like less than, like you're gonna look at like, don't forget to like look at the like larger one, like we said, right? Yeah, Stefan can find some examples too, of like where you're doing what you explained and like what the solution is to it. So we can go over those.
Have you ever seen that such kind of question in your exam?
Oh, in our exams, where they
I
ask,
believe we have.
I found they did that more on my Java exam. I don't know for you guys, like if it's been like for us a couple of years since we had our exam. Did you, in your quizzes, did you have those kind of questions? Or no, like did you have quizzes or anything where they would ask those kinds of questions?
Actually, yes. Not as a quiz in my professional.
Okay, so one of your professor quizzes, like he asked that kind of question to you guys.
Yeah, he asked. For some reason. Yeah.
So was there only like one question like that, or was like, have you guys gone over those in class?
Only a few.
Only a few.
Only a few. Okay, so usually like what you see in class and like if you see it on the quiz, then it's up for grabs for what if the professor is going to like
Test you on it.
test you on it.
Yeah.
Did you, from the one in the quiz, did you guys like understand it? Do you guys have the same professor, by the way? Is there like multiple ones, or is like
There's like 9 sections.
there's 9 sections?
Oh wow.
Wow. Okay.
Yeah, when we were taking it, there was
Like 2.
at the end there was 2 or 4 total.
Yeah, there was like not as many. Yeah. Yeah, this is like the recursion stuff. So functions that call themselves, a big game of telephone. You guys remember this? What's missing here?
Okay, so for
And then here's the fix.
okay, so
Yeah, so
oh wow, okay, yeah, that usually doesn't happen. Like usually all profs are supposed to have the same exam, but I guess they're switching things up now.
yeah, they usually all have the exact same one. So yeah, definitely go off of like what your professor says in class. So yeah, so here's an example where you have countdown. It's recursion because it's calling itself, so it's doing countdown -1 and it's printing the countdown value, right? So fix add a base case. So this is kind of a shitty example, I won't lie to you. Ignore my language. Pardon me. But it's making sure that it's saying like if it's less than 0 or equal to 0, then print this, else print this and call itself. It's basically like the question here is like what's missing, and it's like you have to account for the case where n is equal to 0 or less than 0, and so then we're doing recursion. So for example, if you're doing recursion, you're going to want to account for situations where it's going to be like keeps going through, and one of them is equal to 0 or like any of these cases. So I guess this is what this is trying to say.
Eventually it has to reach an end. So basically like here they're like the end is reached when n is less than or equal to 0.
Yeah, you definitely don't want to be stuck in a case where I guess it is not the worst example, but you don't want to be stuck in a case where it goes on forever. Like you want to be careful of continuous loops with recursion, because if you keep saying countdown -1, countdown -1, it's just going to keep going forever. Like there's no case where it's ever going to stop, right?
I think Python has actually a recursive that of 1,000.
Yeah, so like that's something Python set up, so like because it doesn't want to ruin your computer, but like
it's just generally when you have a recursive function, you want it to perform something repeatedly, but generally you want to force it to end somewhere.
Yeah, so that's kind of what it's like telling you.
So in this point, at this point, it will end if n is
less than or
equal to 0. Which I think this example makes it a little bit clearer. So let's say I give it I pass in 5. So if I do countdown 5, it'll print n, so 5, then it'll call itself again and pass in 4. So 4 is passed in, it's still greater than 0, so it'll print 4, send 3 down, so do 4 - 1, which is 3, call itself again. It'll keep doing that until it reaches 0, where it'll print this, and then terminate all of the functions.
So yeah, here's an example, prints vertically. Yeah, and so then here it's saying, so for this one, we have the else statement says else if n is less than 10, then you can stop. So this is another example where it's like telling you to stop at a certain point. So make sure that there's like, for your code, don't make it go on forever, basically is what like this recursion is trying to say.
So I know that wasn't the best example, but
Yeah, I guess it's like kind of just going over what like recursion is and everything like that. Yeah. Also,
if there are more questions about that, we can record a small video after and post it to YouTube as well as send it to you guys.
yeah, we can also like post a small video of like where they're doing those kind of examples with
With the different big O notation.
Yeah, big O notations.
Yeah. Like we tried to provide a general overview, but like obviously we missed a few things that were important, so we can try and add that and then send it out to you guys later tonight.
Yeah.
Um,
I guess big O notation is like one of the harder things. And then it's kind of for this class, like big O notation, you're making your classes and doing your methods. You're making sure you know, like, I think they ask questions where it's like, you're adding integers or like edge cases, things like that. So did you have questions like that where like you're like adding things and like if like it's in like a certain order, and so you have to remember like that certain order, like what the result would be. So it's kind of like from seeing the code, what's the result going to be, from being given these methods, what methods are you going to have to write, and then analyzing different code to see what the big O notation would be and things like that. And then a lot of writing your own code.
Yeah. So just to go back to what we were doing at the beginning with the different classes, just to provide you a quick example of what I was trying to explain with the inheritance. So, for example, we had the class A. So we have class A, and we have a function. Let's call it results. So it'll return A, and then we have class B, which references A. And we also have result, right? So in this case, if we do so if we print A dot result, it should return it.
I call yeah. You need your. I feel like you forgot something. Do you guys know what he forgot?
Sorry. Shoot, sorry about that. I think we're just going to change this. So let's just call it.
I don't think this is going to change anything.
Okay, yeah, it did. Okay, so sorry. There's some keywords in Python that you can't use. I guess result was one of them. So in this case, if I have class A, the function is 2. So you might see something like this on exam where you have the two different classes. I'm just going to also add another function here and call it 1, and this one will return 1. So right, we have the two different. We have the main class, the main class, and the subclass, which is inheriting from. So class B is inheriting from class A. So you might see something on your exam like. So you see that, and then you might have A is equal to A. Print A dot 2, right? It would ask you, what do you expect the output to be? So because this is class, it's the main class, we expect it to print, when 2 is referenced, we expect it to print A, right? But we might also see something along the lines of, right, print B dot 2. And like what we were explaining earlier, I think it makes sense. It'll reference the one in its own class first. So because this has its own to function, it'll perform what is outlined there. So in this case, it returns B, right? But what happens if we try and call b.1, right? Because there's no one function in there. It'll refer to the one in its like parent class, which in this case, oops,
Oh, you didn't set, yeah, it's saying 1. And then.
Yeah.
Yeah, so it's printing
yeah,
1.
sorry, there was just something left over there. But basically it prints 1 from the parent function itself. So I can change this to 1, 2, 3 just to make it a little bit more clear. But you see it'll print 1, 2, 3 from the parent class. And this is something that is seen on a lot of programming exams, no matter what the language is. They'll give you, especially in object-oriented related stuff, is they'll give you a bunch of classes that are nested, or not nested, sorry, that are like have a parent relationship, and they'll ask you what is the expected result. Or they'll either ask you to write the expected result or select from a multiple choice. I'm not sure if that entirely makes sense, but.
Yeah.
Okay.
What else do you want to go over?
So I had a couple of questions. I'm not sure if we want to go over them together or not. I think these ones are from old exams. These are just like more general programming questions. So
Yeah, so we can, so for this question, you're given, do they call them lit? Like you're given these two lists. So you're given X and you're given Y, right? And it's saying we have this function, we're going to combine X and Y. How are we going to do that? You want to return just one list with both of these combined together.
does anyone have any ideas?
On how to do this.
So we can try that, but I believe that one will just.
Yeah, so let's try that. You guys want to, we want to do that? Then we can try it. Oh yeah, you're in the big O directory.
sorry.
Yeah.
Okay, so this does combine it, but the question specifically asks us to combine it so that it does one from the first list, one from the second list, one from the first list, one from the second list. So
so if you look at it, like when you do this, it just sticks them together when you add them.
Yep.
So if the question was just like, oh, sorry, we should have explained that better to begin with. But if the question was, take these two lists and stick them together, then you do this. So this result is like, okay, but it's not in the order you necessarily want,
yeah.
Right?
And it's also technically not what the question asks for. So there's multiple ways you can go about answering this. Sorry, I also saw one in chat, which we can give that one a try, but I believe it'll do the exact same thing. So if we do X extend Y, okay, I might have made a mistake there because I'm not too familiar with that function. But there's a few ways to go about this. And generally on an exam, you might not have enough time to come up with a full solution, or you might not be able to, sorry, what's the right word? You might not be able to come up with the most proper solution. So what you have to do is come up with a solution that will come the closest to this, to what the question is asking for. So in this case, one of the better ways to solve this problem is to loop through one of the arrays and append from X and then append from Y. And one thing that's also important when writing exams and when you're writing your own code is to so one important thing is to write your assumptions. So in our case, with the way we're going to solve this problem is we're going to have the assumption that assumption that X and Y are the same length. So we would do the standard for loop where we go for I in X. So, or sorry, for I in range of length of X. So the reason we're doing this instead of the for variable in the list is because if we were to do that, we wouldn't be able to easily index both arrays at the, or sorry, both lists at the same time. So if we did for I in X, that would just provide the for loop with the current variable stored in that location of X, but we wouldn't be able to reference Y easily. So the reason we're doing, so that's the reason we're doing for in range, because that will provide us with
The indexing.
the index reference.
Yeah.
So we will do that. And also I forgot to define a new list for us to place the items in. So we will do results dot append, sorry, res dot append xi. So we're going to be appending appending the
Value at X.
value at X to the new list, and then we'll be doing the same for Y. And then we can return the result.
So here's an example, like where for like this case, we're making this assumption that X and Y are the same length, right? What if we don't want to make that assumption? What are we going to do? Oh, yeah, sorry.
Yeah, sorry. We're just going to
Run it. We'll run it first and then you can see. Yeah, so there it does like every other value.
Yeah, because the question asked us to go x0, xy. So x0 is 0, xy is 5, and you can see the pattern follows through with that.
Yeah. So like the way you did it at first, where you add them together, that is technically correct, but we have to read the question properly, which we didn't do, but you have to read the question properly and make sure, like for this case, it cares about the order, right? So then let's say we don't want to make this assumption, for example.
But I mean, the question says x0, y0, dot, 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 x and y and so it might imply the assumption.
Yeah, that is true. It can imply that like X and Y are the same length. So that's true. So you could say like, I'm assuming that X and Y are the same length. Also for this kind of question, it is implying that. And if you want it to be like alternating in order, it doesn't exactly make sense why you'd want it to be alternating in order and then have like a couple at the end that would be like 4, 5, 6, if that makes sense. But just for like testing our own knowledge, let's say like one of them is like M, right? So just to like, let's just change the question and like test our own knowledge to make sure we know how to like change this code for the case where they're like different lengths, I guess. So for this case, you're going to want to say, we'll define a new variable. So we'll say like, what variable do we want to name it? We'll call it L is equal to 0. And then we'll say, if, right, like length of X is greater than length of Y, then do this, right? And we're going to set X equal to length of X. Or sorry, I should say L here. L is equal to length of X. And then we do else. Oh, I cannot spell today. L is equal to length of Y, right? And then down here we go and we say, instead of putting this here, we say in range L, if that makes sense.
And also we'd want to check that that each of these exists every single time. Otherwise we'll have an error where it'll try and pull something out of bounds.
Yeah. And then also you could say, if they're different lengths, you can make sure that neither one of them are, you could look at even different cases. Like, let's say we want to make this like a more thorough answer. We could look at cases where like one of the lengths is 0 and the other length is like also 0, right?
Yeah.
If both of the lengths are 0, like if either one of the like say like length of X is equal to 0, then just return Y, right? If that makes sense.
or just additionally, what you can do, like if the question, like just another like example of what a question might ask you is it might ask you what our original question was, which is just to, which was just to do this. You could in theory also do if the length of X, oh, sorry.
Yes, equals 0.
What you could do is you could just have it,
Yeah, that's another.
sorry. So like another thing you could do if the question asks for it is you could check to see if both are the same. If they are, perform the combination, otherwise just return none. That's just something you can do. Thank you. But yeah, just try and list your assumptions if you have them. It's just better to be on the safe side because the prof obviously doesn't know what you were thinking when you were
And this is the case where like add comments and stuff.
Yeah. So that's why you would want to say that you're assuming that X and Y are the same length. Okay, are there any questions about this question? Or sorry, okay. Okay, so this one's more of a string one. It asks to remove all values from the given string. So okay, so this is what we want the output to be.
And the string you're given
Is hippopotamus.
yeah.
So there's multiple ways to go about this. Does anyone have an idea on how they would go about this?
On top of my head, or let's say for X in around 10, or character in X, and then if it's not a vowel, if it's not a vowel, then add until at least 3.
Yeah, that's actually
perfect. Yeah.
the solution we came up with. So there's again multiple ways about going around this. So let's see what chat has to say. Yeah. Yeah, so pretty much the same, very similar idea to what this person in chat said is, so first we're just going to define our vowels.
Because we can't check for vowels if we don't know, like, if it doesn't know like which ones are vowels, I guess.
So we're going to first define them and then.
And for this case, we're just like not assuming Y. So that's an assumption you might want to say.
Yeah.
For the example they're giving is like hippopotamus with no Y, but yeah.
Okay, so we have the list of vowels, and then we can go for character in S. Oh, we should not use that. So for each character in S, again, sorry, I forgot to define the output string, the empty string. So for each character in S, which is the name of the variable that is being pushed, or that the variable that is being brought into the remove vowels function, we will loop through all of them and see if it's not in vowels. And if it is not in, sorry, if the character is not in vowels, then
You're going to want to append it to the string. I got my voice.
So again, this is just another example where you can do plus equals this instead of doing, so this is the equivalent of result is equal to result plus C. And then when we go through, we can return the result string. Any questions about the way this is structured? Here's just a fun question. What is the time complexity of this?
A fun question.
Yeah. Are you supposed to write code or only so it depends on the prof. Some profs do ask you to write code. Some give you a few different sections of code and ask you which one would achieve the correct result. And that's like a multiple choice question, and some ask you to write it. So it depends on your prof.
Yeah, so ask your prof, like, what kind of questions you're gonna be expecting. Is it only multiple choice, the structure of your exam? You guys might even have different exams. But even if you're only doing multiple choice, like, it's good to practice multiple choice questions, but you should be able to code them yourself too.
Yeah.
Like, if you can code it yourself, then it's a lot easier for you to understand. Yeah.
So does anyone know what the time complexity of this
Oh,
might
yeah.
be? Yeah, exactly. It's O of n because there's one for loop, and this doesn't really add that much. So
Time
yeah,
complexity.
time complexity. O of n is the largest time complexity in this case. So let's just give this a quick run and double check that it works. And as we can see, there's no vowels in the return string. So we've completed that question successfully.
And so, like, if this was a multiple choice question, they could give you this code and it could be wrong, and then say like, oh, how are like, this code is wrong, this needs to be added, this needs to be added. So like, if you can do this question where you write it all yourself, then you can know how to do that multiple choice question.
Yeah. So for an example, what you might see is something like this, and then it might say line missing.
Oh, yeah.
I remember this from my exams, and then it gives you options. Like it might say something like replace line missing with one of the following. So if you have a multiple choice exam, that is a type of question that you might see, and it might give you 3 options. So it'll give you the correct option and 3 wrong ones, or it might even give you 2 correct options, and you have to pick between if you pick either one of them, it might be right.
Or you have to pick both of them and like get another answer. Yeah.
Yeah. So there's multiple ways that professors do it, but generally it's a good idea to at least like get an understanding of how some of these questions work, because this is based on former exam questions. Like these aren't exactly former exam questions, but it's based on them. Okay, so here we have another question, which is given an array of strings, find the average length for each string. So does anyone have an idea how we might go about that? Okay. So there's a few ways we can go about this, but one of them is we're going to loop through the array and gather the length for each string inside of it. And then we're just going to divide it by the number of items in that list. So I keep saying array. It's also a list. So just if I say that, please.
Yeah, no, it's the same thing.
It's the same thing. So first we'll need to define a variable for actually keeping the running total for the different lengths. So we're going to go, I'm just going to call it result again, but we'll set that to 0. And then we can go for, I'm just going to go for s in n, in n. So n is the list with all the strings. So we're going to go for string in s, or sorry, for string in the list. Add the value of the length of the current string. And then, so now that when this loop is done, we'll have the total number of characters in the strings, in all the strings in the list. And then we'll just need to return the
result.
Return the result. So sorry, not return the result. We want to return the result divided by the length of n. So there's like we already see the example down here, but there's 7 items in the 7 strings in the array. This is just the average. This is just the length of each one combined and averaged out. So when we run our string, it should return the same result. And if we did our algorithm here correctly, it should return true on the second line. So let's just give that a try. So our average length was 6.714 and it returned true. So our algorithm was correct. Are there any questions about this one? No. Okay. Moving on to another question. This one asks find the number of palindromes in any given array of strings. How fast can you make this? So I'm just gonna sorry, just a second.
Okay, so a palindrome, I don't know if you guys remember it, but it's the same thing that can be, it can be forward, it can be backwards. It's like something that's repeating forward or backwards.
Yeah, if you reverse it, it'll remain the same. So there's a few ways to go about this.
It's like the name Hannah,
yeah.
for example.
There's a few ways to go around this. So we want to, okay, my solution has it with returning just the list of palindromes. So we can do that, or we can just do the number. I'm going to do the list. So there's a few ways to go about this, but basically,
And so that's kind of like an assumption we're making.
Yeah.
So you could say like, we're making this assumption that we're going to return it in the list. So you can define your own return values if it's asking this kind of question where you're coding it yourself.
Yeah. So we're going to assume that it wants a list returned. So what we're going to do is we're going to do for string in n. So n again is the list. We can do reverse string is equal to s dot reverse, I believe. And then we can check if s is equal to rs, then we can append it to the list that we're creating with the ones that are in the correct order. So if we do that, we can finally return E, which is the list with all the ones that are palindromes, and we should be able to run the code. Oops. Okay. Sorry. Okay, so I probably confused that with a different language, but there's another way to go about this, which is using the string modifiers. So this one here will just provide the string in the reverse order. And as we can see, it returns only the ones that are the same backwards and forwards. So sorry about that. The dot reverse function doesn't work. Can you try to do it using recursion?
1 second, let me think about it. I feel like so for like this case, it's bad to be using recursion because our method is being given a list of arrays, like a list.
Yeah.
Like it's being given a list. It's not being given just like one and being asked if that one value is a palindrome or not. It's being given a list of various palindromes, and because of that, we don't want to be doing recursion for it.
However, I think we could do a similar question where we just check one string and see if that one is a palindrome. So we can give that a try. Actually, I'm going to just open a new file here. Okay, define a function, and we're just going to pass in the string. So this would be probably a far less efficient way of doing this, but we can do. So what we want to do is we want to check the
String.
check the two on the far end on each end of the string, if that makes sense. So let's say we have string 1, 2, 3, 4. We want to check one time we'd want to check 1 and 4, and then we want to remove those if they're the same. And then we want to check 3 and 4 to see if they're the same. So the way we would go about this is we want the first character in the string. So I'm just going to call this one A. That should be this, if I'm not mistaken.
Yeah.
So that should, in theory, give us the first one in the list, and then we should be also able to get the last one in the list. I'm just gonna have to double check this. I'm sorry, it's been a while since I've done this.
I guess you have to do 0, right? You're saying the first one.
I think B is empty.
Is empty, yeah.
Can we just do length of the
Oh,
string?
yeah. Sorry, yeah. We can just do.
Yeah, make sure the indexing in like Python is like very specific. So I guess like go over your indexing before you write your exams.
Just gonna double check this.
Oh yeah, it's gonna be -1.
Sorry about that. So we're gonna do this.
I know you're gonna want to write this on the outside. Length -1.
Yeah, yeah. Okay, so yeah, this will return the outside 2 words. So what we're gonna want to do is check. So after we get the 2 on the outside, if A is equal to B, then we're gonna want to return we're gonna want to pass in the string with the first and the last one removed. So just to get a better idea of what's going on, I'm just going to print the string every single time it's passed in.
And then we're gonna want to have an if they're else, return false as well.
So you see, that's not right. Sorry about that.
These are 2 blocks, 2 columns.
Sorry.
Yeah, 2 columns.
Yeah. No, sorry about that. Just check. Sorry.
Yeah, go for it.
I think the last iteration is an empty string.
Yeah. Hold on.
Okay.
Yeah, sorry. I just have to double check this. It's been a while.
So I'm just gonna add, while he's doing that, I'm gonna add my else statement. So if they're not equal, we're gonna want to return right away, right? We're gonna want to return false.
Okay.
And then we're also gonna want to add at the beginning, we're gonna want to add an if statement and say if length of S is equal to 0, then return true. Right. And do you guys know why we're doing it at the beginning instead of at the end? That we're checking and returning true here.
Has to be done before comparing the value.
Exactly. So we want to do it first because we don't want it to iterate over again when there's a 0 length, because that would be pretty bad.
Okay, so what we want to do here is length of S minus. That's not right. Sorry about that. But why is this? Why is this recursive? Okay, so basically what we're trying to do is like I'm trying to make this a recursive example. I'm basically for a palindrome, it has to be the same going in and out. So what we would do is we would check the outmost 2 and then remove them and then pass the remaining characters back inside. And then it'll check if those 2 are matching. And if they match, it'll just keep looping and removing the outside-most characters if they match. Otherwise, it'll return false.
And so for this example, like this is recursion because we're using the palindrome and we're calling it itself. But before, the example we couldn't do recursion because we were given like a list of the different values. So this case, we can do it because we're only given 1 value and then we're allowed to use recursion.
I don't know why this isn't working though.
What happens if you do if you make two columns next to each other, the third parameter is just the distance, the offset.
Sorry, I
do
don't.
ones.
Oh yeah.
Don't. There we go. Okay, there we go. Sorry.
Yeah.
So that's what I was
Yeah.
missing. Yeah, there we go. Okay. So if we pass this in, it'll slice off the various
It should be return palindrome, right?
yes, it should be. Sorry.
Yeah.
Yeah. Sorry. So yeah, there's something we made a small mistake here, but basically the idea is it's like you'll use the recursion when you have a some sort of repeated action. So in this case, the repeated action in this example would be check if the outside two are equal. If they are, remove the outside two and call the function again, and keep testing that until you run out of characters to test. And then after that, if there's no characters left to test and they're all equal, return true. Otherwise, on the first one where it's not where it's not matching, you can return false. And we'll fix this and upload a working example.
How do you call the function again?
So you just call it.
Like I scroll down to the bottom, and it just says palindrome, so there's no printing.
Oh yes, sorry, you're right. Sorry, it's been a long day. Yeah, so this case it returns true, so it was working. Okay, let's just try adding.
So there is something missing from this code. So, okay, so this example, it's going to say false because that's correct. But we're going to want to look. So the first example he gave here is we have this. And if you have this example going in, can you tell me like what the problem with the code is for this one here? So there's a problem with the code when it has exactly this example. So the problem we have is there's two different types of numbers or strings or whatever going in. There's one with a length that is an even number, and there's one with a length that is an odd number. And so this case, we're saying if s is equal to 0, and that's only for even numbers. So we're removing the ones on the ends. And if it's an even number, it's going to have 0 at the end. But if there's another case and say, or ln of s is equal to 1. And so this is the other case if it's an odd number of values, right? So we're going to want to have these two in case it's even, in case it's odd. You could say, I made this assumption that's only doing even numbers or whatever, but it's best to like look at both cases. The other thing about this is you can say like, okay, there would never be a case where an even number of strings, a string with like an even length is going to return 1. So that's okay for us to do both of these things.
Let's say palindrome of 1. Let's say palindrome of a string of just 1. A is equal to 1, B is equal to 1.
So that should return
Let's try.
true.
Yeah.
And we can also do the example that was listed above. And we can see that one also returns true. But if I add, let's say, a 5 here, so it's no longer a palindrome, it will return false.
Yeah.
So what happened was just 1. So it will work if it's just a 1. We'll upload this code later so you can play around with it a little bit and see if it works.
And so do you guys know the reason it's returning 1 is true? If you go through the code? Yeah. So length of s equals 1. So it's returning true. And that's the first thing it asks. Is it 0? Is it 1? And so it's not only doing that for if the recursive one comes in and it's 0 or 1, it's also doing that if the first value that comes in has a length of 0 or 1. So
and it's assumed that a palindrome of just one character is
a palindrome.
Yeah.
But what if we remove the length s equal to 1? What happens?
If we remove that, let's try it.
Okay, so it still works.
Yeah, that's
Yeah.
because 1 equals to 1, like A equals to 1, B equals to 1.
Yeah,
And then he will cut off the 1 and then he returns entry strings.
yeah, exactly. But the problem about if we did this and then, so like that case, it would still work. But if we did this, for example, and then we try to run this, what's going to happen? That's still true.
Okay.
Yeah.
So sorry, that was a mistake on our end.
Yeah. So it's still going to like cut it off.
Then it cuts off 1 and then it cuts off 2,
And then it cuts off the last
Yeah.
one. Yeah.
Yeah, you're right. Sorry. Yeah, that was a
But I
mistake on our
mean,
end.
it's either way, it's still right. So
Okay. Yeah, okay. So I think that answers the side question. Hopefully, hopefully you understand, you get a little bit better of an understanding of recursion here. I mean, this might not be the best example, but hopefully it's at least a little bit more of an example about recursion. So if there's no more questions about that one, we'll go to the fifth question, which is given an array, return the numbers with an even number of digits in the list. And the thing is, we cannot convert this to strings. So does anyone have an idea on how we might go about that?
Oh, dividing by 10 several times.
Yeah, we can do that. So that's what our solution has. So the first thing we want to do is we want to create the return. So it wants us to return everything in a list. So we're going to start by
making our empty list.
Making an empty list. And then we're going to loop through each of the items in the list as always. So we can go for I in N. Hopefully that's all clear now. We can go and then we can just take a copy of the item in the list. So we can do.
I don't think you want to do.
Yes. Yeah, for I and N, if
Module 2 equals to 0.
yeah, we can try. Let's try that one first. So if I in N, oh, sorry, if I in N, sorry.
Yeah, so this is kind of the case where it's good to remember the module.
Yeah. So let's see if that works.
We're not really returning anything.
Yeah. So so for this question, it wants us to return a list.
So the question asks an even amount of digits.
Even amount of digits, yeah. So this one will just return the numbers that are
Even numbers.
Even numbers.
Not an even amount of digits.
Yeah. So we're
So it's like number of times divided by 10.
yeah. So this solution is technically wrong. If the question said return a list which only contains even numbers, it would be correct. But for the question it's asking, it is wrong. So the way that we did this is we did a while loop. So for while the new value is not equal to 0, we then did the new value is equal to the new value divided
Divided by 10.
This is integer or
Floor division.
yeah.
So it's not gonna return any decimal points, and so that's when you do like a double division kind of thing. So if you don't want any decimals, then do that.
So we're just going to start a counter here. And that counter is going to count every single time it is divided.
The issue is the number 0 is 1 digit, right? And
Yes.
and if you let's say you say number 1.
Yep.
Number 1 is also 1 digit. Number 0 is also 1 digit. Right?
Yes.
Yeah. So that is true.
0 cannot be an even digit.
Okay, so if we'd want to account for that, we can add an if statement that like that says if the number is 0, don't include it. So if it's less than 1 and
I don't think we have that. So C.
yes, yeah, sorry. Okay. Okay, so basically what this is doing here is that so after it's done the loop of dividing integer division by 10,
Yeah.
it'll add it to the counter. And then if the counter is sorry, if the value is less than 1, the value being passed in, sorry, not the value being passed in, if the remainder is less than 1 and
It's done it.
The module is equal to 0, it'll then append it to the list. So this is the list of items that have even values. So you see here it added 0, but let's say we didn't want to include 0, we can just say and not I is equal to, or sorry, yeah, I is equal to 0. So this should then not include 0 if we don't want to include it. But all the numbers here have even numbers. So 66, 2 numbers, 55, 2 numbers, 55, 2 numbers, 1, 3, 3, 3, 4 numbers. I think that's 6 and that's 8. And none of the other ones are included.
So does that answer make sense to everyone?
So what's the point of if new I is less than 1?
Well, so we can remove it and then we'll show you the result of why we need that.
I think that's so okay. So this solution was given to us by someone else. So there was a few edge cases that they had encountered which required that specific line.
Because I do feel like new I has to be equal to 0 as if while loops.
Yeah, here we go. We'll take a look to see if there's any examples where it is 0. Yeah, so there's no examples where it is above 0, but I think it's just a good check to have because there's probably a few scenarios where it might end up being greater than 1.
Is it when it's like 10, 300?
Oh, yeah. I think maybe if we do, I think this was an example. No.
What about just 100?
Sorry. Oh, I see. Okay, I'm not exactly sure why that's there, but it was recommended that it be in there.
But I assume that if you guys didn't add it, then you wouldn't lose any marks.
This is more to just get an idea of how like a question like this is done. This is not like the only correct answer.
And also if you're adding like, for example, here we added like new I less than 1, or then the other one we said like we're for like the example before, I remember I added the length is equal to 1. For the for this case here, remember I added like length of S is equal to 1. We checked that one. It's okay if you add more if state like examples into your if, as long as it doesn't affect the result. And like for this example, if we added the length of S is equal to 1 in this, it's actually a bit more efficient because we're not going through everything to check all the time. If it's like it would have to still, if it's like equal to 1, it would have to still run through all this code again, right? So if you add more if statements so that it doesn't have to run through again, then you're making a more efficient answer. And so that's also good. But try not to just add like if statements, like ongoing if statements. That's also not good practice, but like you can add some additional input to the if statement. And those are all the examples we have
Yeah.
today.
I'm not sure if anyone has any more questions. So if you have any more questions or concerns about this particular or about any topic for this exam, you can send me an email. Hold on just a second, sorry. So we'll if you go to this website here, it's a GitHub page. It has all the code that we had today, as well as the presentation, and there'll be a link to the slideshow as well as the Zoom recording. But if you have any more questions, you can contact me. My email address, you can find it on that page. It's academic@IEEE-uOttawa.ca. So if you have any questions about any specific topics that you'd like a little bit more help with, you can send me an email and I will try my best to answer them. Right.
Thanks, guys.
Thank you.
You guys want to take some cookies to go? Go for it. Yeah, no
course.
problem.
Are there any questions in chat? Thank you so much for coming.